All right, so this is 5.1, part 1. We're going to talk about angles. We're going to talk about positive and negative angles. We're going to talk about how to convert between radians and degrees to radians. You guys have heard about radians. You've talked about the units. You need to understand what makes up an angle, a positive angle versus a negative angle, those sorts of things. So today's going to be a little bit of vocabulary.
Do you need a calculator for this?
You can use one, yeah. A little bit of vocabulary, and a lot of application kinds of things. This first slide shows us the makeup of an angle. Okay, an angle is made of two rays that have a common endpoint, which is the vertex of the angle. And there's two sides to the angle. There's a terminal side and an initial side. The initial side is where the angle starts. So the initial side is where the angle starts, and the terminal side is where the angle ends. Does everybody understand that? Your angle is always going to start on the positive side of the x-axis, right here. This is always going to be your initial side. Now, whether the angle is positive or negative will tell you the direction that you go. But if you think about this, guys, in our coordinate plane, right, this is 0, or also 360 degrees, because we're used to thinking in degrees. Up here is 90, over here is 180, and down here is 270, correct? Okay, now we're going to talk about radians in a little bit. But how many degrees are in half of a circle? 180, good. How many degrees are in one whole circle? 360. Okay, good. That's good to know. Very good information. So when we talk about the direction of angles, okay, you might want to draw this. If I tell you that an angle measure, okay, this is 0 or 360. Again, this is 90 up here. 180 is half. 270 is 3/4. If I tell you that you have an angle measure, our theta is 285 degrees. Is that a positive number or a negative number? Positive. Do you see a negative in front of it? Okay, so you're going to start right here. The initial side is always right here, the positive part of the x-axis. And where am I going to go in between for 285? Good. I'm going to go all the way around, and it's somewhere over here between 270 and 360. So everybody see that? All right, so if I told you, God bless you, this angle was negative 130. The only thing, good, the only thing that negative does, guys, is change the direction. Okay, we're still at 0, 360 here. So negative 90 would be down here. Negative 180 would be here. Negative 270 would be here, and this would be negative 360. So you start here on the initial side. Where would negative 130 be?
At the bottom.
Like over here, right?
Yeah.
So that's how you would draw it. That negative sign just tells you the direction. You always start right here on the positive x part. If it's a positive number, you go around counterclockwise. If it's negative, you go clockwise. Questions? Very good, guys. Yes, sir.
Wouldn't that be negative 360?
Yes, that's what that is right there.
Okay.
A little tiny negative sign. All right, let's look at this. We're going to talk now, and I want you guys to just think for a second. You told me that one whole circle was how many degrees? 360. Right? So does it make sense that 1 degree is the same as 1 out of 360 degrees? Okay? So 45 degrees is the same as 45 over 360, correct? Okay. If you simplified that, how can I simplify that? What does that become? Okay, what goes into both 45 and 360? 5. Okay, 5 goes into 45 9 times, and 5 goes into 360 how many times? What's 360 divided by 5?
65.
Not like. Tell me what it is.
65, right?
What's 360 divided by 5? 72. All right. What number goes into both of these again? 9. So 9 goes into 9 once, and 9 goes into 72 how many times? 8. So 45 degrees is how much of one circle? It's 1/8. Okay, do you guys see that? We think in degrees. You guys have seen this a million times. You've talked about degrees. Your temperature is in degrees. We're now going to start talking in radians. This is where your pre-calc stuff comes in. Y'all have seen the unit circle. I know you have because you do it in Algebra 2. You may not have memorized or anything, but your unit circle looks like this, right? It's still here. This would be 0 or 2 pi. That's the same as 360 degrees. 2 pi is the same as 360 degrees. And I'll show you how to do the conversion there. But up here, your 90 degrees is the same as pi over 2. 180 degrees is the same as pi. 270 is the same as 3 pi over 2. And I'll explain to you how that comes about. And if you don't know where something is on the unit circle, you can convert it, and it's not that big of a deal. But we're going to be talking a little bit now for the next few sections about radian measures. This is what a radian measure is. This is a good explanation over here. All right, let's talk about what a radian is.
Isn't there like a chart like that gives you like each of the radians or something?
I'll give you the unit circle, but this is the actual measurement of a radian. Sarah?
Do you need to know, like, the unit circle?
You're not going to have to memorize it, no.
Okay.
Okay, the distance, guys, from the center of a circle to a point on the circle is called the what? Right here, from the center of the circle to a point on the circle. It's called the radius, correct? You guys agree with me? It's called the radius. So try to visualize this. I know it's kind of hard, but try to visualize. If I took this that I have highlighted and I kind of pulled it apart here, I took it off of where it is and I scooted it over here. Do you guys see how the radius is the same as this piece of your arc right here? Mm-hmm. One radian measure, like 1 degree, it's 1 out of 360. 1 radian, it's just a measure from the center to a point on the circle. Well, there's 6 of those around the circle. So if I have 1 radian there, and then I have 1 here, and then I have 1 here. Do you guys see how half of your circle, right? Half of your circle is 3 radians. Do y'all see that? So if my whole circle is 2 pi, half of it would be how much? 1 pi. Good. What would a quarter of it be? Okay, you're right. What if I cut that in half? Half pi. That would be our 90 degrees up here. And if I had it down here in 3 pieces, if I had 3 pieces of it, right, it'd be 3 pi over 2. Bye, honey. This 90 degrees is the same as pi over 2. 180 is the same as 2 pi over 2, which is just pi. 270 is 3 pi over 2. And 1 whole circle is the same as 4 pi over 2, which simplifies to 2 pi. So you're talking about the same measurements. It's just in a different unit. So we are going to convert now in a second. What I just talked about right there is what's in this figure here. But it's still 1 whole circle that's made of 360 degrees. But 360 degrees is the same as 2 pi. It's an equivalent measure. So what we're going to work on here is converting. Going from degrees to radians, from radians to degrees. Now, this is not anything you guys have to memorize. You don't have to memorize, oh, how do I convert this? What am I supposed to do? You just have to think a little bit. Sometimes you're going to be given numbers that are in degrees. And you'll know it's in degrees because it's going to have what little symbol in the top of it? It's going to have little degrees. And it's going to say convert. Well, if you start off in degrees, you should then convert to what? Radians. If you start off in radians, it'll have a pi symbol in it. So if you're starting off in radians, then you're converting to, if you started off degrees, you went to radians. If you start off in radians, then you're going to degrees. You're always going to use the conversion factor that in 1 whole circle, half of it is either 180 degrees or 180 is the same as pi. Those 2 things are the same. They're equivalent. So you'll get questions that say like this. A lot of times it's not going to say go from one to the other. But in letter A, if I look at my problem, if it just said convert, okay, fine, write down 60 degrees. Obviously, I'm starting off in degrees, so I'm going to what? Radians. So think about this. You're going to have a conversion factor. It's either going to be pi over 180 or 180 over pi. What do you want to cancel out? The degrees. So where would I put 180 degrees? In the numerator or on the bottom? On the denominator? I'd put it in the denominator. So then what goes on top? Your pi. You don't have to memorize, okay, if I'm going from here, I have to do this. You just have to think. Whatever you want to cancel out goes in the denominator. So now you just simplify. When we write our radians, we leave it in terms of pi, meaning pi should be in your answer, and in a fraction. You don't want a decimal. So if it simplifies nicely, great. If it doesn't, you just leave it as a yucky fraction. That's okay. The first thing I would do is I would say, ooh, this has a degree and a 0. I can cross off both of them, right? And you guys can use your calculator. But what number goes into both 6 and 18? 6. 6 goes into 6 once. 6 goes into 18 3 times. So I'm left with what on top? Pi. And what am I left with on the bottom? 3. So 60 degrees is the same as pi over 3 in radians. That's it. So in letter B is starting off in what? Radians. It's pi over 6. So that means I want to go to what? Degrees. So where would I put pi so that it cancels out? On the bottom. Where would I put degrees? On the top. So pi cancels with pi. What number goes into both 6 and 180? 6 goes into 6 once. 6 goes into 180 30 times. So I have 30 degrees. That's it. Yes. So here I come up with this. First of all, guys, it says it's negative. What does that mean? If I was going to draw it, what does that mean? You go the opposite direction, okay? It still is going to be negative when you convert, so make sure you keep it negative. But I'm starting off in what measurement? I'm starting off in radians. I know I'm starting off in radians because I have a pi in my problem. I don't have a degree symbol. So where is 180 going to go and where is pi going to go? Pi on the bottom because I want it to cancel out and 180 degrees on the top. Good. So right away, look, my pi's are gone. Now you can multiply -7 times 180 and then simplify that way if you want to. Or you could just say, okay, what goes into 12 and 180? Okay, 6 goes into 12 2 times. 6 goes into 180 30 times. Okay.
Could you cross multiply?
You don't cross multiply, no. You can cross cancel, but you can't cross multiply because there's no equal sign. Can I do anything else here? 2 goes into 2 once. 2 goes into 30 15 times. Okay, so what is -7 times 15? -105 degrees. So if I asked you to draw that, it's -90 here, -180, right? I'd start here and at negative would be down, so it would be over here somewhere between -90 and -180. But it's -105 degrees. It's just the direction. That's it.
Just want to clarify, you cannot.
Right here on the positive side, yeah. All right, what do you notice about 952?
Degrees.
It's in degrees. Very good. What else do you notice? It's bigger than 360. This is bigger than one whole circle. That's okay. That's totally fine. But I can convert. I can go from 952 degrees to radians. Where would 180 degrees go? On the bottom. Good.
Why not 360?
And where would, because it's only pi and 180. That's it. And where would pi go? On the top. Okay. So right away I see, okay, good, the degree signs cancel out. And it's either pi over 180, guys, or 180 over pi. That's it.
Why do the degree signs cancel out?
Because they're on the top and the bottom. Remember, if anything is exactly the same on the top and the bottom, it cancels out. So the degree over degree, the degree divided by degree would cancel out. Now I see that 2 goes into both of these, correct? They're both even. So what's 952 divided by 2? Sure. 952 divided by 2. 476. I don't know why I wrote 67. 76. All right, what's 180 divided by 2? 90. Okay, great. Are they both still even? Okay, so then 2 again. What's 476 divided by 2? 238. And then what's 90 divided by 2? 45. All right, anything else? 238, is that divided by 3?
No.
Why not?
Because if you add them,
If you add them, good. 8 plus 3 is 11, plus 2 is 13. 13 is not divisible by 3. So can I simplify those two numbers anymore? So it just stays as 238 pi over 45. That's it. You do not turn that into a decimal. It's 238 pi over 45. All right, again, when we talk about angles in standard position, we've already talked about this. You guys have seen this. Standard position means I start right here on the initial side. This is what kind of an angle is this one if it went upwards?
Positive.
This is a positive angle. Good. This angle is in standard position, but which way did it go? So it went downward, so this is a negative angle. Good. All right, what do you notice about this one?
it went completely
It's
wrong.
It went completely around. It went from here, went around one whole time, and then a bit, right? So it would be bigger. It would be bigger than 360.
That's positive.
It's positive, and that's fine, but it's bigger than 360. What do you notice about this one? It went around. It's negative, but how many times did it go around? 1.5, like a little bit. That's okay. That just means that the measurement, the number, is going to be bigger than 360. And we're going to talk about that. We're going to talk about direction and stuff like that in just a minute. Hang on. Co-terminal. If you're a co-captain, you're a captain with someone else. If you're a co-pilot, you're flying the plane with someone else. For co-terminal, I want you guys to write this down. Co-terminal. A lot of times you're going to be asked to find one positive and one negative angle. If you start off in degrees, you're going to add and subtract 360. Let me write it differently. If you start off in degrees, to find the coterminals, you're going to add and subtract 360. If you start off in radians, what do you think you're going to add and subtract? What's the same as, yes, good, 2 pi. Now, this is as simple as it appears. The only thing I can stress to you is you have to start with the angle, meaning, let me show you why here in a second. Let me show you. Here's a circle, right? Well, we'll do it this way. Here's an angle measure. Say this angle measure is 35 degrees, okay? This angle right here is 35 degrees. You can have an infinite amount of coterminal angles, meaning an unlimited amount. So a coterminal angle shares terminal sides where it ends. So just say I went the positive direction. I went all the way around. How much is this when I go all the way around? A whole circle and then a bit, right? So I go from right here. I go all the way around in a bit. Do you guys agree that I just took that 35 degrees and I just added 360 to it, correct? But I came back to the exact same spot. Same thing happens if you start at your initial side and you come around. I went 360 almost. I subtracted. I took 35 and I took 360 away. When you do your coterminal angles, you are adding and subtracting an entire circle. I could add another 360 and I'd come back to the same spot, right? And then another. And then another. So there's an unlimited amount of coterminal angles you guys can find. You're going to be asked to find one negative and one positive. This is how you would do it. This is how you would show me. If I start off with 30 degrees, okay, I'm starting off, this is how you guys would show me, 30 degrees. What am I going to add and subtract for coterminal if I'm in degrees? Plus minus 360. Good. So you guys would write 30 plus 360 is what? 390. Okay, that's your positive. Then you would start off with your angle, 30 degrees minus 360, which is what? Negative 330. Do you guys see how you have one positive and one negative coterminal angle. If I said to you guys, draw me an angle that's 30 degrees, and then I said, draw me 390, it would be the exact same angle. You just went around the circle one time. If I said, give me 330, you would just go the opposite direction, and you'd end up at that same angle. It's a little tad bit more difficult when you're in radians, just because you have to do a teeny little bit of fraction work. But instead of adding 360, I have to add and subtract what? 2 pi. So again, you start with the angle. So pi over 3 plus 2 pi. When I'm adding fractions, I have to get a common what? Denominator. So my common denominator between 3 and 1 would be 3. So if the bottom is 3, I multiply the top by 3 and I get 6, right? So what's 1 pi plus 6 pi? 7 pi, good, over 3. That's your positive coterminal angle. Now, if I wanted to get a negative one, I would say pi over 3 minus 2 pi over 1. Now, again, I need a common denominator. So my common denominator would be 3. So this would be 6 pi, right? So what's pi minus 6? 1 minus 6. Negative 5 pi over 3. Those are your two coterminal angles. Those are coterminal. So somebody asked a good question last period. It's going to come up in the example here, and I'll show you. But so say we start off with negative 170 degrees. That means I'm going to add and subtract what number? 360. So start with the angle. Negative 170 plus 360. Calculators, what is negative 170 plus 360? What is it? 190? Okay, 190 degrees. Now I'm going to say negative 170 minus 360. What does that give me? Negative 530 degrees. Do I have one negative and one positive? Yes. So if I started at negative 170 and I went one whole circle around, I'd end up at positive 190, but I'd be in the same exact spot. That's what that's saying. So somebody last period said, well, what happens if I start off with the number and I add 360 to it and it doesn't become positive? Or if I subtract it, it doesn't become negative? That can happen, guys. What if you start off with 400 degrees and I said, give me a negative and a positive? Well, a negative, for the positive, you would say 400 plus 360 and get what, 760? Okay, fine. So now I need the negative one. So 400 minus 360 is how much? 40. Wait, that's not negative. What do you think I should do? No, I need a negative. I'm going to minus another circle. You just minus 360 again. You just keep adding till you get a positive. Keep subtracting till you get a negative.
So circles would go around like 2 times?
Uh-huh. Yep. That's the beauty of coterminal. You can go around 100 times. You'll still get the same thing. So 18 pi over 5. 18 pi over 5, okay? Obviously, this is in radians because it has pi. There's no degree sign. So I know I'm going to add and subtract 2 pi. Remember, you start with the angle itself. So 18 pi over 5 plus 2 pi over 1. What's my common denominator between 5 and 1? 5. So 5 on the bottom becomes 10 on top, correct? What's 18 plus 10? 28 pi over 5. Do you guys have any idea where that is in the unit circle? No, that's okay. It's fine. But is it positive? Good. Okay, so let's now go back and let's find the negative. So 18 pi over 5 minus 2 pi. Well, common denominator was what? 5. So this becomes 10. Agreed? What's 18 minus 10? 8 pi over 5. Is that negative? So what should I do? I'm going to subtract 2 pi again. Common denominator again. 5. This becomes 10. What's 8 minus 10? Negative 2 pi over 5. Do I now have one positive and one negative? Perfect. Good. We're going to talk here about the length of a circular arc. Okay, let's talk about what that means. Let me draw you a picture. All right, here's our circle. All right, here's the middle-ish. All right, you're going to have a piece of pie, right? This is your theta. This is the central angle that they're talking about. This is your radius. And when they say that the arc subtends a central angle, all that means is it's across from it. This is the arc that they're talking about. It's like the crust of the piece of pizza. You guys see that? That makes sense? So here's the formula for the arc length. S equals R times theta. R is a radius. It's the length from the center of the circle to a point on the side of the circle, on the outer rim of the circle. And then your theta. So you're going to use this formula. You're going to find stuff. It's super easy. The thing you have to remember, I need everybody to write this down, is that theta, when you go to calculate this, theta has to be in radians. How do you think they're probably going to give it to you in a problem? In degrees. But do you guys know how to change it to radians? Yes. So 2 teeny tiny examples, and then we're done for today. Okay, this is just the same picture that I was just showing you. No big deal. So here's 2 types of problems that you'll see. Okay, A says find the length of an arc of a circle with a radius 10 that subtends a central angle of 30 degrees. So here, let's draw a picture. All right, here's my center. What did they tell me theta was? 30 degrees. And my radius is 10. And I'm trying to find the crust of the pizza. I'm trying to find right here. All right, so the formula is S equals R times theta. S is the arc length. R is your radius. Theta is the angle. What do I have to do with 30 degrees before I can throw out this formula? I have to change it to radians. So 30 degrees to radians. Where does 180 go and where does pi go? 180 on the bottom. Good. And pi on top. So the 0 and the degrees cancel out. 3 goes into 3 once. 3 goes into 18 6 times. So my theta is 30 degrees, but it's also what? Pi over 6 in radians. What did they tell me the radius was? 10. So you literally go 10 times pi over 6. So this becomes 10 pi over 6, and simplify your fraction. What goes into both 10 and 6? So it'd be 5 pi over 3 meters. If it says round to the nearest whatever, then you, in your calculator, would hit 5 times pi and then divide it by 3. But if it doesn't tell you to round to something, you leave it in terms of pi. Yes, ma'am. Hold on. Go ahead, Sarah. Now, B is a little different. If you read B, okay, let's draw a picture so you guys can see it. It says a central angle theta in a circle has a radius of 4. So this is 4. And it's telling you that this arc length is how much? 6 meters. What are we trying to find here? No, they told us what the arc length was. Yeah, we're trying to find theta. We're trying to find this right here. It's the same formula, guys. I'm still going to use S equals R times theta. I just got to fill in what I know. What is S in this case? 6. Good. What is R? 4. And I don't know what theta is, right? So how would I solve this? I'm going to divide both sides by 4. So theta equals... What's theta equal? No.
No, 3 over 2.
There you go. There you go. All right, we good? All right, you guys did a really, really good job today. You're going to have a web assign. 5.1 web assign is not due until Monday. It's a tad lengthy. We're going to finish up 5.1 next week. We're going to start 5.2. This stuff is not easy, so we're going to take a few days to get through it. But it's important that you guys pay attention and focus.